So in today's lesson, we are going to talk about how you can use the Pythagorean theorem to prove whether a right triangle is a right triangle. So let's go ahead and pause the video for a moment, open your spirals to a new blank page, and write the title of today's notes at the top of the page. So the most important thing to remember when doing this is that it has to work for the Pythagorean theorem. It has to work in the equation a squared plus b squared equals c squared. And it has to be balanced on both sides of the equation. So if they give you three side lengths, A, B, and C, you have to be able to plug in those side lengths for A, B, and C and make this equation true by making the left and the right side of the equation equal. The hardest thing about plugging in your side lengths is they don't tell you, here are your legs, here's your hypotenuse, here's A, here's B, here's C. They just give you three side lengths and tell you to prove if it's a right triangle or not. So the most important thing to look at when you're looking at those three numbers is whatever the largest number is your hypotenuse, it's your C. So remember, your hypotenuse is always your longest side in a right triangle. And then it really doesn't matter which one's A or B as long as you know that the other two are your side lengths. So when you're given three side lengths, C is always your longest side length. So go ahead and pause the video here and copy this slide into your notes. So this slide has a vocabulary word on it. Any three natural numbers that we can plug into the Pythagorean theorem, a squared plus b squared equals c squared, that make the equation true are called Pythagorean triples. Pause the video and take a minute and copy this definition into your notes. So let's look at two examples together. They are giving us three numbers, 7, 24, and 25, and they're asking us to tell whether the given side lengths are for a right triangle. So again, the math is already done for us, and this one's pretty easy because the numbers are put in order, A, B, and C, but they're not always done this way. So we have to remember when we plug it into our Pythagorean theorem that our largest number is going to be c squared, and then the other two numbers are our legs. It doesn't matter which one is A and which one is B. So we have 7 squared plus 24 squared equals 25 squared. We're going to go ahead and solve that out, solving both sides of the equations to see if it's balanced. So 7 squared is 49, 24 squared is 576, 25 squared is 625. Add 49 and 576, and we get 625 equals 625. This is true. 625 does equal 625. So because it's true, it fits the Pythagorean theorem. The Pythagorean theorem proves that this is a right triangle. The side lengths form a right triangle. So these three numbers would be called a Pythagorean triple because these three numbers make a right triangle. Let's go ahead and pause the video and copy this example into our notes. So here is a second example. Again, 12 is our largest number, so we're going to plug 12 in for C. And then A and B are 5 and 8. Doesn't matter which one's A, doesn't matter which one's B. So we're going to solve it out. 5 squared is 25, 8 squared is 64, 12 squared is 144. Add 25 and 64, which is 89 equals 144. That is not true. 89 does not equal 144. So this does not form a Pythagorean triple because it makes a not true statement when you plug it into the Pythagorean theorem. Again, the Pythagorean theorem and everything that we do with the Pythagorean theorem is very simple. So I hope that you guys are finding this to be simple and making lots of sense for you. Let's get this copied into our notes. Pause the video and then we will do some practice problems on our desk. So let's get out our markers and our expo markers and our socks so that we can do a couple practice problems on our desk. Let's go ahead and try number 1 on our desks. I want you to tell me whether the side lengths that are given form a right triangle or not by plugging the 3 side lengths into the Pythagorean theorem and seeing if it makes a true statement. Pause the video now and try number 1 on your desk. Okay, so I hope that most of us have tried number 1 on our desk. So let's go ahead and work it out together. You have 3 squared plus 4 squared equals 5 squared. 3 squared is 9 plus 16 is 4 squared equals 25. 16 plus 9 is 25 equals 25. So I am out of room. I cannot fit it in there. But this does form a right triangle because 25 does equal 25. Go ahead and pause the video and try number 2. All right, so again, we've got 8 squared plus 10 squared equals 14 squared. 8 squared is 64 plus 10 squared is 100 plus 14 squared is 196. So we have 164 equals 196, which on this planet is not true. If it were, I would go into banking and make a fortune. So it's not true. So this does not form a right triangle. We've got some decimals on number 3. So go ahead and pause the video and try number 3 on your desk. So we've got 5/10 squared plus 1 2/10 squared equals 1 3/10 squared. So 5/10 squared is 25 hundredths plus 1 2/10 squared is 1 44 hundredths equals 1 69 hundredths. So then we're going to go ahead and add these two together. 144 hundredths plus 25 hundredths. We have 169 hundredths equals 169 hundredths. And it does. So this forms a right triangle. Pause the video and try number 4 on your desk. All right, so I had to erase a little bit of number 3 to make room for number 4. Let's go ahead and work out number 4. We have 18 squared plus 80 squared equals 82 squared. 18 squared is 324. 80 squared is 6,400. 82 squared is 6,724. So then we're going to add 6,400 plus 324, and we get 6,724 equals 6,724. That is correct, so that forms a right triangle. Pause the video and try number 5 on your desk. All right, number 5 is 8 squared plus 15 squared equals 17 squared. 8 squared is 64. 15 squared is 225. 17 squared is 289. 225 plus 64 equals 289, which is equal to 289. That is a true statement, so this does form a right triangle. Pause the video and try number 6 on your desk. Number 6 is 5 squared plus 6 squared equals 9 squared. 5 squared is 25. 6 squared is 36. 9 squared is 81. We can add 25 and 36 to get 61, which does not equal 81. So this does not form a Pythagorean triple. Number 7, we have decimals again. So pause the video and try number 7. So number 7, we have 2.4 squared plus 2.5 squared equals 3.6 squared. So 2.4 times 2.4 is 5.76. 2.5 times 2.5 is 6.25. 3.6 times 3.6 is 12.96. So we have 5 and 7600ths plus 6 and 2500ths equals 12 and 100th, which does not equal 12 and 9600ths. So this does not equal a right triangle. Pause the video and try number 8 on your desk. So number 8, we have 60 squared plus 80 squared equals 100 squared. 60 squared is 3,600. 80 squared is 6,400. 100 squared is 10,000. 3,600 plus 6,400 is 10,000, which equals 10,000. And number 8 is a right triangle. Good job, guys. We've got a couple more problems that we're going to try. So let's keep on going. The directions change slightly, but I just want to show you that even though the directions are different, what they're asking us to do is still the same. So the directions here say to determine whether a set is a Pythagorean triple. But we know that 3 numbers that form a right triangle are considered a Pythagorean triple. So by saying yes or no, if it forms a Pythagorean triple, you're also saying yes or no that it forms a right triangle. So really your directions are the same. You're doing the same thing you've already done. I just want you to be familiar with the word Pythagorean triple so that when you see that in your directions, it doesn't throw you or confuse you on what you're doing. So go ahead and pause the video here and try number 9 on your desk. So for number 9, we have 3 squared plus 6 squared equals 9 squared. And 3 squared is 9 and 6 squared is 36. And 9 squared is 81. 36 plus 9 is 45 equals 81. And 45 does not equal 81, so this is not a Pythagorean triple. Pause the video and try number 10 on your desk. Number 10 is 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25 equals 25, which it does, so this is a Pythagorean triple. Pause the video and try number 11 on your desk. Number 11 is 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. 13 squared is 169. 144 plus 25 equals 169 equals 169, which it does. So number 11 is a Pythagorean triple. Pause the video and try number 12 on your desk. Seven squared plus 24 squared equals 25 squared. 7 squared is 49. 24 squared is 576. 25 squared equals 625. 576 plus 49 equals 625, which equals 625. Those are equals, so number 12 is a Pythagorean triple. Pause the video and try number 13 on your desk. 13 is 10 squared plus 24 squared equals 26 squared. 10 squared is 100. 24 squared is 576. 26 squared equals 676. 100 plus 576 is 676 equals 676, which it does, so number 13 is a Pythagorean triple. Go ahead and pause the video and try number 14. 8 squared plus 14 squared equals 26 squared. 8 squared is 64. 14 squared is 196. 26 squared is 676. 196 plus 64 equals 260, which does not equal 676. So number 14 is not a Pythagorean triple. All right, guys, hopefully you guys are getting the hang of this, and this is something you're doing really great at. We've got 2 more to try. So go ahead and pause the video and try number 15. Number 15 is 10 squared plus 16 squared equals 19 squared. 10 squared is 100. 16 squared is 256. 19 squared is 361. 256 plus 100 is 356, which does not equal 361, so 15 is not a Pythagorean triple. All right, pause the video and try your last problem on your desk. Number 16. 16 is 9 squared plus 40 squared equals 41 squared. 9 squared is 81. 40 squared is 1,600. 41 squared is 1,681. 81 plus 1,600 is 1,681 equals 1,681, which they do, so 16 is a Pythagorean triple. All right, guys, hopefully you're definitely getting the hang of this, and it's making lots of sense using the Pythagorean theorem to prove if a triangle is a right triangle or not.